The sum of the bits here is 127, and the sum of the bits here, right here, is 255. Alright guys, so this is what we are looking for. Now this is what we have to be adding, and this is what we have to be adding. Now we get our network address first. What is our network address? Our network address, sorry, I put this, is 172.16.0.0 prefix 17 now, because we have the default CIDR of 16 and we have borrowed 1 bit, so we have to add 1 to 16 to give us 17. That is now our classless CIDR. And we now look for our broadcast address. So normally I get the broadcast address using this way. Now the broadcast address is the sum of the remaining bits in each octet to be added to that octet on the network portion. Okay, on the network address, not network portion, but the network address. Now this here is representing the third octet, so we add this 127 to whatever that is in this third octet to give us the broadcast address for that octet, and whatever is in the fourth octet we add it to whatever is in the fourth octet of the network address, the same octet of the network address, or the same portion of the network address. Now we're gonna have 172.16.127.255. That is our broadcast, because we add 127 to this 0 and we add 255 to this 0. So the first valid IP address here is 172.16.0.1, and I'm supposed to put here F, so we can see that we are dealing with F. And the last valid IP address here that we abbreviated as L is 172.16.127.254, because with that one you only subtract 1 from here, so all of its state remain the same. Now your subnet max, always you have to go with your subnet max, because this is what tells you how to configure your subnet max in your devices. Now with the subnet max, it's telling you that how many bits are part of the network portion. So we have CIDR 17, so we say 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8 16 1. So now the sum of the bits here, the whole of this is 0 0 0 0 0 that 0 0 0 0 0 0. Alright, that's it. So the sum of these bits here is 255, the sum of the bits here 255, okay, and the sum of this bit here is just 128, and that's right here. So our subnet max is 255.255.128.0, because there's nothing here, so it is a 0. Some people will put 128.255. That 255 is already here, it's already in the broadcast address, so it cannot be repeated here. Okay, so you divide the bits. Next network address would be 172.16.128, simply because this is 127, it's not ended yet, but this is 255, it has ended, so therefore it will make this value change to 128 in the next subnet, and then the 255 will turn to 0 because it is already exhausted. So we have our prefix or CIDR or /17. The same thing here, the broadcast address would be 172.16.255.255. Why? Because why 255.255? Because the sum of the bits remaining here is 127, and the sum of the bits remaining here is 255. Now this 127, we have to add it to this 128. You can see that 127 plus 128 gives you 255, and then that 255 that is already there, this 255 right here, we add this 255 to this 0, and then it gives us exactly that. So we can say 127 plus 128, sorry about 126, equals to equals to 255. So this is exactly what we're looking for. Now when we do this, we have 255.255 and the first valid IP address is equals to 172.16.128.1. Simple. Alright. Now the last valid IP address is 172.16.255.254. The subnet mask right here remains the same, so you have to pay attention to that. Your subnet mask will be the same because this is what we call full or fixed length subnet mask. So some will call it full length, some call it fixed length. Oh, I'm putting 172. I'm crazy. 255.255.128. Right, that's right. Now these are our two subnets, and you can see it is correct because we have 255, 255. So if we have to go for the next subnet, we get out of this 16, which is not right. So we get our two subnets, and each of these subnets is providing room for at least 32,766 valid IP addresses with a block size of 32,768, subtracting 2 from that. Okay guys, so I hope to give you guys another sample, and then perhaps that should be okay. I'm just gonna have to give you guys one more sample, but these are, sorry, I'll give you two examples. Okay, I'll give you two examples, and then from there we close it right from there, and then we'll come next tomorrow. Alright guys, so let's take another sample. I can wipe this out because it's a video, so it's a fine thing. Let's just try to wipe this out quickly, and then we go with this. Get all this out. Now our question is, we need 8 subnets. Okay, 8 subnets, and if we have 8 subnets, that would be, how much do I look for? Right, so 30,000, 15,000, let's say 7,000 users. Okay, alright, 7,000 users. So we need 8 subnets, and then we need 7,000 users. So that is basically what we are looking for, and then we're gonna have to do some subnetting to get that right. So you guys are gonna follow me because I need to get that right. Okay, now let's look at this. Okay, so let's get all this out here. All of these things have to get out, or perhaps we just delete the whole of this. Alright, now let's go back to work. Now in order for us to get 8 subnets, how many bits do we need to borrow? We need to borrow 2 bits. No, if we borrow 2 bits, 2 to the power of 2 gives us 4. We need to borrow 3 bits. If we borrow 3 bits, 2 to the power of 3 is 8. So that's good. So we're gonna have to borrow all these bits. We borrow 3 bits, and we are left with 5 bits in this octet. Okay, so this is what we're gonna do. So we say we're gonna borrow 3 bits. So 2 to the power of 3 is equals to how much? 2 to the power of 3 is not 23. Oh my god, it's 8. You're crazy. So 2 to the power of 3 is 8, and how many bits are remaining? It is 3 out of 16 gives you 13. So we say 2 to the power of 13 instead of 15 now. So 2 to the power of 13 should give you how much? 8,192. I think that should be the correct one. 8,192. Let me make sure that that is correct. Yeah, that should be correct. Okay, so I am just trying to do some calculation right from here. Say 2 to the power of 13. Well, it gives me 8,192. So that's correct. Alright, so this, we're looking for 8 subnets, and each subnet should give us 7,000 users, and that is fine. We are okay with that. Now we're now going to subtract 2 from here, and then say equals to 8,190, and that is our valid host range. Now this is exactly what I am looking for. Now how many bits are borrowed? What is the sum of the bits borrowed? Okay, the sum of the bits borrowed. Now it's very important that you get the sum of the bits borrowed, because